Welcome to Hold the World. This wonderful museum houses many fascinating specimens, but today I've chosen a select few that I find of particular interest. So pick a room or pick an object. This 112-million-year-old fossil was found in Brazil. It was donated to the museum in 1989, and it's the only one of its kind on public display in Britain. It had to be left in a bath of acid for 9 months to dissolve the limestone around it. It's about 50 centimeters long and paper thin in places. It certainly looks very fragile. Clearly, it's the upper jawbone of some kind of animal. But what kind? If you pick it up and have a closer look, there are clues. Eyeballs are too soft to fossilize, but eye sockets can show how big an animal's eyes were. Could those huge eyes mean that it was nocturnal, or were they simply because they gave great accuracy for hunting during the day? What could that bump on its snout be? Was it a defensive horn, a way of cooling off, or perhaps a means of attracting a mate? That bony swelling on the end of its snout looks a lot stronger than the rest of the skull. What would the animal have needed that for? The fact that all the teeth are of the same shape tells us that they belong to a reptile. But why would each of its long, sharp teeth curve inwards like a hook? This skull belonged to a creature called Anhanguera, which means old devil in the extinct Tupi language once spoken by Brazilian Indians. And it was a fearsome flying predator, a pterosaur. It preyed on fish. Those large eyes would have helped it to scan the water for prey. The tip of its snout was strong enough to withstand a high-speed impact on the water. And those hooked teeth enabled it to keep hold of a slippery fish. Clearly, in life, this was a very unusual animal. It was much larger than any modern flying creature, and unlike anything on Earth today. The crest on its nose was about 3 centimeters high and probably helped Anhanguera to attract a mate. We know from finds of the same species that it stood only about 80 centimeters tall. But it had a huge pair of wings that were up to 5 meters across. When a large bird, such as a swan or an albatross, takes off, they do so with a running start. But pterosaurs, such as Anhanguera, are thought to have taken off with one almighty leap. Detailed analysis of the skull shows that the specific parts of the brain responsible for balance and control were very much enlarged. So once Anhanguera was airborne, It must have been an excellent and very agile flyer. I'm glad I'm not a prehistoric fish. What could this skeleton belong to? It has a backbone, so clearly it's a vertebrate. There are no obvious legs, so it probably didn't walk on land. But I can tell you, this is not a fish. A clue to this creature's identity is the fact that in reality, it would be much, much bigger. This skeleton belongs to a sea-dwelling mammal. And what's more, at up to 33 meters in length, it's the largest animal on the planet, the blue whale. Have a closer look at some of its features to find out what makes this creature very special indeed. At its full size, that lower jaw is 6 meters in length, and it's the largest bone of any kind on the planet. The jaws open up to take in vast quantities of water, filled with thousands of tiny shrimp-like creatures called krill. To maintain their size, blue whales need to eat 4 million krill every day. Take a close look at those pectoral flippers. They're the ones that come out of the side there. They're noticeably similar to the skeleton of a human hand. The ancestors of whales were once land-dwelling mammals that gradually evolved to live in the oceans. And in order to maneuver in water, their front feet became the pectoral flippers we see today. See if you can find 2 floating bones underneath the backbone at the rear end of the skeleton. Those are all that is left of the whale's ancestral pelvis. They appear to be floating in mid-air because they're attached only to muscle. As the whale has no legs, it was presumed that the pelvis no longer served a purpose, just as the human tailbone doesn't. However, recent research has found that they might actually serve as an anchor for the whale's genitalia. This particular blue whale skeleton is that of a female. The body was found on a beach in Ireland in 1891 and was sold to the museum for £250. It took several months to strip the whale of its blubber and flesh before the skeleton was ready to be sent from Ireland to the museum. If it had been 20 years later, the whale would have been put in the museum's whale pit, which was just about 100 meters outside that window. There, whale carcasses were buried in sand while their stinking flesh rotted away in preparation for display. I'm sure the neighbors were glad when the museum got rid of the pit in 1939. This skeleton has many revealing characteristics, but they can only really be appreciated when seen at its correct size. This skeleton weighs 4.5 tons, but when covered in flesh, the blue whale can weigh a massive 175 tons. So to help it collect the huge amount of food it needs every day, the blue whale has evolved a special way of feeding, using sheets of baleen hanging from its upper jaws. That is made of keratin, the same stuff as our fingernails.
The whale engulfs up to 80 cubic meters of water filled with thousands of krill. Then it uses its baleen like a huge sieve, expelling the water but retaining the krill. To pump blood around such a colossal body requires a huge heart, which is about the size of a piano. And because its body is so large, it only beats 8 to 10 times a minute. And it can be heard 3 miles away. But the melodic song of these solitary giants can be heard from one side of the Atlantic to the other. Blue whales can dive hundreds of meters in search of krill. If you or I were to try that without special equipment, we would die from the extreme pressure. But the blue whale has a set of extraordinary abilities that make it possible for it to do so. To preserve oxygen, it can slow its heart down to 3 beats per minute and even temporarily shut down key organs. Its right and left lower jaw bones can open to more than 90 degrees, allowing it to consume 480,000 calories in one huge mouthful.
This is the skeleton of a plant-eating dinosaur that roamed the warm, dry environment of North America about 150 million years ago. It was discovered in a quarry in Wyoming in the United States in 2003. Right now, it's 1/75th of its full size, which in reality is about the same as that of a rhinoceros skeleton. No one knows its sex, but the museum have given it the nickname Sophie, so we'll assume that it's a female. And they're particularly proud of her because she is the most complete Stegosaurus skeleton so far discovered. Pick it up and try to imagine what she was like in life.
The name Stegosaurus means roof lizard. It was given it because the scientists who first studied this dinosaur believed that those vertical plates lay horizontally to form a kind of armor. Today we know that they stood vertically and are slightly offset plate to plate, but the name Stegosaurus remains unchanged. Scientists once believed Stegosaurus had a brain about the size of a walnut, which gave it a reputation as being somewhat dim-witted. At one point, it was even suggested that it had a second brain at the base of its spine, though this was soon disproved. But after scanning the skull, one American expert described its brain as the size of a bent hot dog. So maybe Sophie wasn't quite as stupid as we once thought. Look at the size of those hind legs in comparison to the front ones. The earliest dinosaurs walked only on their 2 hind legs. But about 200 million years ago, Some herbivorous dinosaurs, such as Stegosaurus, evolved to walk on 4 legs. You might think that Sophie was a mild-mannered vegetarian, but Stegosaurus was no pushover. Look at the end of that tail. To protect itself from predators such as the toothy and vicious Allosaurus, Stegosaurus had a fearsome spiked tail for swinging at attackers.
Even though Stegosaurus has been known about since 1877, its fossilized remains are still rare, with only a handful of skeletons and a few isolated bones or plates found here and there. The discovery of this near-complete skeleton is not only a thrill for visitors to the museum, it's revolutionizing what we know about this dinosaur. Scientists right here at the Natural History Museum have painstakingly scanned all 360 bones to reassemble her digitally, and that has revealed some fascinating details about the way that her body worked.
Most of the time, Sophie would have ambled around at about 1.5 kilometers an hour. But at her top speed of 6.5 kilometers an hour, those large hind legs must have made her walk in a somewhat ungainly fashion. Those plates on her back most likely served multiple functions. They were possibly some kind of display to others of her kind. They might also have helped her keep cool by dissipating heat from her body. A CT scan revealed that the plates would have been too weak to provide any meaningful protection from an attack. However, they would at least have made her look bigger. But in the event that a predator did come close, those spikes on that tail were far from passive. So if there were any predators around, I wouldn't expect them to be making an easy meal of Sophie.
Pick another drawer. Over 100 years ago, Lord Walter Rothschild, an eccentric millionaire with a fascination for the natural world, received a package all the way from New Guinea. Rothschild had a 400-strong team of collectors working all over the world who regularly sent him natural curiosities of all shapes and sizes. But this particular parcel held a very special specimen indeed. Rothschild found a large butterfly and knew instantly, because of its huge size, that it was a species new to science. It was, in fact, the largest butterfly in the world, and he named it after King Edward VII's wife, Queen Alexandra's birdwing butterfly. If you pick it up and take a closer look, you will see evidence of what we would now consider to be a quite unorthodox method of collection.
Look at those bright red hairs on her body. These butterflies lay their eggs only on the toxic Aristolochia vines. Their caterpillars feed on these unsavory leaves and retain their toxicity all the way through metamorphosis until adulthood. Perhaps these red hairs function to warn predators of their distastefulness. The Queen Alexandra's birdwing, like all butterflies, has a long tongue called a proboscis, which she uncurls and probes into flowers to get out the nectar within. And she's quite a fussy eater, only content to feed on the flowers of 2 or 3 species of vines, which are restricted to the forest of Popondetta in Papua New Guinea. Look at those large holes in its wings. These wonderful butterflies live in one small area in the jungles of Papua New Guinea, where they fly high above the forest. Rothschild's collector, Albert Stewart Meek, was unable to reach high enough with a net, so he used a small specialized shotgun filled with fine shot called mustard seed to knock the butterfly out of the sky. And that's why this specimen is peppered with holes. Life has dealt this particular butterfly a bit of a bad hand, but she didn't always look so battered.
At Rothschild's request in 1907, a year after Meek shot that first female out of the sky, Meek went back to search for more. To his amazement, he discovered even larger specimens of the same species of butterfly, some with a colossal wingspan of 28 centimeters. However, Meek still had no idea what the male looked like, until one day he had the bright idea of finding some caterpillars and waiting for them to metamorphose into adult butterflies.
The males are about 1/3 smaller than the female, but what they lack in size, they make up for in dazzle. Their brightly coloured patterning explains why it took Meek such a long time to identify them as the male rather than as an entirely different species. Since mass deforestation in Papua New Guinea, the Queen Alexandra has become critically endangered. So it's important the species maintain their numbers, or our grandchildren might not be able to see this spectacular butterfly flying anymore. If a male sees a female, he will hover above her, showering her with pheromones, and if she is receptive to his amorous advances, they will mate. Hopefully, now we are one step closer to a healthier population of Queen Alexandra's birdwing butterfly.
Welcome to London's Natural History Museum. This is part of the herbarium, one of the many rooms in the museum that's usually out of bounds to the public. These cupboards contain thousands of plant specimens, but today there are also some other very special objects from elsewhere in the museum that, for the first time ever, you yourself can handle. So go ahead and pick a drawer. This 395-million-year-old little creature is a trilobite. They may not have the size and fame of dinosaurs, but for me, trilobites are just as impressive. They thrived on planet Earth for 250 million years, which is remarkable when you consider that we, Homo sapiens, have only been around for about 350,000 years. There were tens of thousands of species of trilobite, and this particular specimen, at its true size, was just about 5 centimeters long. It's known as a tower-eyed trilobite, and you can probably see why. Usually, museum staff would tell you off for picking up something like this without supervision, but today, I think you're allowed to do so.
Look closely at the trilobite's tower-like eyes. They rise up from its body, probably so that it could see above the silty seabed on which it lived. The two cylindrical eyes gave it a 360-degree view, ideal for detecting predators and prey. Trilobites were among the first creatures to develop complex eyes. As experts learned more about the ancient world in which trilobites lived, they realized that predatory fish and cephalopods were also evolving and flourishing around that time. So now it's thought that trilobites most likely evolved spines as a defense. The eyes of this particular species had shades like visors, which would have prevented sunlight from blurring its acute vision. The presence of the visors also settles any speculation that this creature was nocturnal.
Trilobites had a hard shell that protected their soft inner body parts. This exoskeleton is one reason why they thrive for such a long time. And it's also why this and many other trilobites are so remarkably well preserved. Fossils of trilobites are often found curled up like this. It's probably a defensive posture that they adopted when they were disturbed. Their soft legs are rarely preserved, but we do have a pretty good idea of what they look like.
When trilobites curled up in a ball, their spines would have protruded in all directions, giving them greater protection from potential predators. And when the danger passed, they could uncurl and carry on in their hunt for food. Each leg had a gill attached to it, which enabled it to extract oxygen from the water. Trilobites evolved body parts to suit practically every ocean environment, which helped them survive for hundreds of millions of years, far longer than we humans have done. But even creatures as successful as trilobites couldn't survive a huge extinction event. Maybe the fact that they've lived for so much longer than we humans have done so far can act as a reminder of our own fragility and the responsibility we have not only to the survival of our own species, but to all life on Earth.
Pick another drawer. Dragonflies are among my favorite creatures. Not only are they strikingly beautiful, they're extremely ancient. They evolved 300 million years ago, long before the dinosaurs, and they were the first creatures we know of to fly. There are 106,000 dragonflies in the museum's collections. This particular specimen, at its correct size, is only 4 centimetres long. It may not be the largest or even the prettiest dragonfly, but it does have one skill that sets it apart. A problem with observing dragonflies is they fly around at such speed that you don't get much of a chance to look at them up close. Until now.
Look at the junctions between the dragonfly's wings and its body. They are different to almost all other insects in that each wing is independently operated. They beat up to 90 times per second and give the dragonfly great mobility for hunting. It's hard to miss those enormous eyes. See how they take up almost its whole head. Each eye is made up of 30,000 hexagonal lenses, which point in almost all directions and give the dragonfly a near 360-degree vision. Each lens can sense the tiniest of movements. When it comes to insect vision, the dragonfly is unrivaled. Look at the tip of the tail. These are claspers which the male uses to grab the female before mating with her. Halfway along his body, tucked inside, he has a rigid and spiky penis that's shaped like a spoon to remove the sperm of a rival male from a female before he deposits his own.
There are thousands of species of dragonfly worldwide, and they come in all shapes and sizes. But this one is very special. It can be found on almost every continent on the planet. And now, thanks to genetic testing, scientists have proved that this species is one huge interbreeding international population. But how did individuals of this species achieve such a global presence? They flew. This dragonfly is called the globe skimmer, and it's been given that name for very good reason.
Thanks to those independently articulated wings, the globe skimmer, like all dragonflies, has remarkable maneuverability in the air, which makes it a very efficient hunter. But the globe skimmer's name doesn't stem from its maneuverability. It was given that name because it migrates. And it migrates further than any other insect. The globe skimmer has enlarged hind wings which allow it to travel incredible distances, gliding on the winds while feeding on other small insects. These dragonflies gather in their millions following the rains to travel up to 18,000 kilometers over oceans and mountains and deserts, and they've been found in Africa, Asia, Australia, Europe, and the Americas. The migration of the globe skimmer is an epic story of the natural world that has only recently been discovered. So you can't help but wonder how many more secrets our planet has left to be revealed. This is a rat flea, the main species responsible for the spread of the bubonic plague. This is an anatomically accurate digital version of the Oriental rat flea. It was made using high-resolution scans which were then remodeled to allow handling and enlarging in virtual reality. The Oriental rat flea is a parasite and a carrier of human disease. In the 14th century, this particular species played a part in the deaths of 50 million people. Behind the eyes you will find a set of antennae tucked into grooves. These can detect heat, light, and the changes in air current caused perhaps by a nearby animal, and even the traces of carbon dioxide that animal exhales. Those eyes are very different to ours. Fleas' eyes are not as complex as yours or mine, but they can sense light. Scientists have conducted experiments to show that if a light is turned on and off to simulate the shadow of a passing creature, the flea will jump in a wild attempt to land on the host. Look at the mouth parts. Fleas feed with a kind of hypodermic needle with which they pierce the skin of the host in order to feast on its blood. Hold the flea so that you can see how flattened it is. The flea's squeezed body shape allows it to rapidly and efficiently maneuver through their host's fur. Take a close look at the angle of the hairs on the flea. Notice how they are backwards pointing and positioned at a sharp angle. That helps the flea to stay attached to its host by hooking onto the host's hairs if the flea starts to fall. Over millennia of evolution, the flea, like many parasites, lost its wings and instead developed a pair of powerful legs. These incredible legs contain resilin, an elastic protein that allows it to jump huge distances and reach 140 G, that's 20 times the acceleration of a moon rocket re-entering the Earth's atmosphere. It's not so surprising that the flea is despised by many and considered as nothing more than a tiresome pest. But its acute powers of detection, remarkable parasitic adaptations, and incredible physical characteristics mean you can't help but marvel at this unappreciated little creature. The bird that laid this egg was the extinct flightless elephant bird. It was huge. It stood 3 meters tall and weighed half a ton. This accurately recreated digital version of the egg was made using high-resolution scans, which were then remodeled to allow handling and enlarging in virtual reality. I first went to Madagascar in 1960. And after much searching and some help from the local people, I managed to get hold of some fragments myself.
Now, would they fit together? These two certainly did. To fasten them temporarily, I used adhesive tape. With a jigsaw, you at least know that all the pieces belong to the same puzzle, but this was different, much more exciting and tantalizing. For I had no idea how much of the egg was present, or whether all these pieces belonged to one egg or to several. With mounting excitement, I managed to get piece after piece to fit together. At the end of an hour, I had 2 halves. And to my joy, they fitted together perfectly. As I held it, I had little difficulty in imagining the country as it must have been only a few hundred years ago, when great numbers of gigantic birds over 10 feet tall strode majestically through the swamps.
Look closely at the many dark pores on the surface of each fragment. Oxygen would have passed through these pores, allowing the chick inside to develop and grow large and capable enough to defend itself from predators when it hatched. The amount of protein, calcium and other minerals that it took to produce this egg would have been a huge drain on the mother's body. Scientists think that because of this, elephant birds only produce one egg every couple of seasons. Despite some obvious signs of age, in life this egg would have been a uniform white colour. The elephant bird had no need to camouflage its egg. The bird was extremely powerful, and any predators might have received a lethal kick. Whoever collected this egg must have been so amazed by its colossal size, they scribbled it on the surface of the egg, 25¼ by 34½ inches, which would make it 160 times the volume of a boiled egg that you might have had for breakfast. Birds have evolved hard eggs that do not squash when they sit on them to incubate. The thickness of this shell suggests that even though this bird was very large and heavy, it would still have brooded the eggs. The particular area that this egg was found is now near a town called Tuliar, and it's thought that the elephant birds would come to the beaches here in order to nest in large numbers. Nobody knows why for sure, but maybe it was for the safety in numbers, the warmth of the sand, or the food found on this particular beach. There were many strange predators in Madagascar, such as the giant fossa, an extinct relative of the mongoose and the now extinct Malagasy crowned eagle. But elephant birds managed to thrive until the arrival of one predator even more strange and deadly than all the rest. Humans arrived on Madagascar around the 11th century. Scientists think elephant birds were driven to extinction not by hunting the adults, but because humans feasted on their eggs. Another sad example of the devastating effect we humans can have on the natural world. This fossil skull was found in South Africa and acquired by the museum in 1895. It has a somewhat ferocious appearance, a thick bottom jaw, and a set of sharp canines that suggest that it was a predator. It belonged to an animal that's been called Cynonathus, which means dog jaws. This anatomically accurate digital version of the skull was made using high-resolution scans which were then remodeled to allow handling and enlarging in virtual reality. The teeth of Cynonathus look like those of a carnivorous mammal because it has incisors, very large canines, and teeth like molars in the upper jaw. Reptiles, such as dinosaurs, usually have teeth that are more uniform in shape. Cynonathus had a long snout and large nostrils, suggesting that it had a good sense of smell. On examining the long snout, some scientists have speculated that a young Cynonathus may have fed on its mother's milk, a behaviour typically associated with mammals. Look at the area around the snout for concentrations of small indentations, which are thought to be the imprints of foramina, openings of blood vessels and nerves. They suggest that Cynonathus had sensitive whiskers on its snout, similar to those found on a mammal such as a dog or a cat. Look underneath the skull, through what would have been the lower jaw. Inside is a secondary palate, the roof of the mouth that separates the nostrils from the mouth, allowing Cynonathus to breathe at the same time as eating. Most reptiles don't have a secondary palate and have to hold their breath when they eat. Generally, reptiles must swallow chunks of their food in one piece, but those long, large holes near the back of its skull mark where muscles were once attached. Coupled with those molar teeth, which are usually only found in mammals, those muscles suggest Cynonathus was capable of chewing and grinding its food. Cynonathus lived more than 200 million years ago, at a time when reptiles ruled the world. But with its teeth, whiskers, and wolf-like appearance, Cynonathus could easily be mistaken for a mammal. Well, this curious creature is believed to be a stem mammal, a reptile with mammal-like features which was a precursor of the modern mammals we know today. So how mammal-like was Cynonathus in life? Well, most reptiles are covered in scales, but if Cynonathus had whiskers, which are just a type of hair after all, then could it also have had a layer of fur covering its entire body? The presence of hair has led some to speculate that Cynonathus also had certain glands over its body. Could these glands have secreted a milk-like substance? Well, the presence of a secondary palate, the roof of the mouth, could be evidence that the young of Cynonathus suckles from these glands on its mother in the same way as most mammalian young do today. Reptiles like crocodiles, monitor lizards, and snakes lay eggs. But could it have been the case that Cynonathus gave birth to live young, like mammals do today? I'd like to think so.